Okay, so one more time, I really hope that you have gone through these 4 questions and given them a try on your own before coming to this video for help. C tells us that a solution of hydrogen chloride is splashed on zinc metal. A sizzling reaction leaves a salty crust on the surface of the metal and gives off hydrogen gas. We're going to do the same thing we were doing in class. We're going to identify the reactants and the products before we do anything else. It tells us straight up that our starting reactants are hydrogen chloride and zinc metal. So I've got a salt, hydrogen chloride, and I've got a metal, which is zinc. Now, hydrogen chloride is made of H+ ions and Cl- ions, which balance each other with a +1 and a -1 charge. So HCl is my chemical formula for hydrogen chloride. Meanwhile, my chemical formula for zinc is just Zn. Now, I did tell you straight up what one of my products was hydrogen gas. But I'll admit it's difficult here to identify what the other product has to be. In order to do that, we need to recognize that this is a single replacement reaction. And I can identify that by looking at the fact that I came in with a pure element like zinc, and I left with a pure element, hydrogen, H2. So what happened here is that the zinc and the hydrogen actually swapped places in a single replacement, which means I went from having hydrogen chloride to instead having zinc chloride. All right, I do wish we had a chance to get to this one in class, because you might feel that that was a little unfair. We didn't get a huge amount of time to talk about these single replacement reactions, but that is what's going on here. I am flipping out hydrogen for zinc in a single replacement reaction. Now, in order to get the chemical formula for zinc chloride, I need to recognize that a zinc ion, Zn, has a 2+ charge, and a chloride ion, Cl, has a -1 charge. To balance, I'm going to have twice as much chlorine, which means overall, ZnCl2 is my chemical formula. Okay, so now I know all my reactants, I know all my products, and I can set up my chemical reaction. I can set up HCl plus Zn, forming ZnCl2 plus H2. Go back to the original description. It tells us that a solution of hydrogen chloride is splashed on zinc metal. A sizzling reaction leaves a salty crust on the surface of the metal and gives off hydrogen gas. So there are our products and reactants. Now that I've figured this out, balancing isn't too bad. If I put a 2 in front of the HCl, then I get 2 hydrogen here for 2 hydrogen here. I also get 2 chlorine for the 2 chlorine here. And then my single zinc balances my single zinc, so I am happy with that. One last thing you might want to do is to point out that this HCl was dissolved in water. This zinc was a solid. This zinc chloride was a solid, and this H2 was a gas. Just a good thing to keep track of when you're trying to imagine this reaction actually happening. All right. So I encourage you now, you've seen that one, to go try D, because D is another example of single replacement. But let's go through. It says that chlorine gas, reminding you that's a chlorine molecule, is bubbled through a solution of sodium bromide. An orange liquid, which is molecular bromine, precipitates, forms, and sinks to the bottom of the container. Table salt forms, but remains dissolved in the water. So, let's look at our reactants, and let's look at our products. I told you that we're starting with chlorine gas. And sodium bromide. I'm ending up with, at the very least, table salt, which is sodium chloride. And this orange thing, which is molecular bromine, so bromine molecules. All right. So I have to memorize that chlorine forms Cl2 and bromine forms Br2 molecules. When it comes to the salts, sodium chloride and sodium bromide, I should realize that sodium has a charge of +1, chloride has a charge of -1. So those guys are balanced, and I get NaCl, table salt. And then over here, sodium has a charge of +1, bromine has a charge of -1. Those guys are balanced, so I get sodium bromide. Okay, so once again, this is a single replacement reaction. Just like on the last example. And what happened here is that the chlorine and the bromine swapped places. So keeping that in mind, let's write out our full chemical equation here. Let's take NaBr plus Cl2, forming NaCl plus Br2. Once you've got this down, our balancing is pretty straightforward. We need a 2 here and a 2 here. That gives us 2 sodium, 2 sodium. It gives us 2 bromine, 2 bromine. It gives us 2 chlorine, 2 chlorine. Everything balances out, and we're happy. One final thing that we might want to do is say that my NaBr that was dissolved in water is AQ, aqueous. My Cl2 was a gas. My NaCl stayed dissolved in the water, AQ, and my Br2 became a liquid. Reading out the description one more time, it says that chlorine gas is bubbled through a solution of sodium bromide. An orange liquid, molecular bromine, forms and sinks to the bottom of the container. Table salt forms but remains dissolved in the water. So sure enough, that matches the description of the reaction. That is our balanced chemical equation. So that's good for our first video. I'll put up a second.